Right now, as you breathe, 40 billion cells in your body are dying. And this is what keeps you alive. Every exhale carries away the remnants of cellular sacrifice. Every heartbeat pumps fresh oxygen to replace what has been consumed. You are not a thing but a process. Not a statue but a river, constantly dying and constantly being reborn. This is the first paradox of existence. Death is not the opposite of life, but its most faithful companion. In the time it will take you to finish watching this, the universe itself will have aged 7,200 seconds closer to its final moment. Every tick of every clock in every corner of reality, counting down to something we can barely comprehend. Yet here you are, a collection of dying cells housed in a temporary arrangement of matter, capable of contemplating infinity itself. How is this possible? The coffee growing cold on your desk follows the same law that will one day freeze the last star in the universe. The second law of thermodynamics doesn't care about your morning routine or the birth of galaxies. It simply states that everything moves from order to disorder, from hot to cold, from complexity to simplicity. Your coffee surrenders its heat to the air, just as every star will eventually surrender its nuclear fire to the void. This is not a flaw in the design of reality. This is the design itself. But if everything ends, what does it mean for something to last forever? Can infinity have a boundary? Can eternity run out of time? We speak of the universe as if it were immortal. Yet every observation tells us it had a beginning. 13.8 billion years ago, space and time themselves burst into existence from a point smaller than the period at the end of this sentence. If the universe had a birthday, why shouldn't it have a death day? The paradox deepens when you realize that you are made of star stuff that is billions of years older than the Earth itself. The calcium in your bones was forged in the dying moments of massive stars. The iron in your blood was created in stellar furnaces that burned for millions of years before our solar system even existed. You are not separate from the cosmic process of ending and beginning. You are an expression of it. Consider the magnificent absurdity of your existence. Every atom in your body has been cycling through the universe for billions of years. You have breathed air that was once breathed by Shakespeare, by dinosaurs, by the first bacteria to produce oxygen. The water in your cells has fallen as rain on alien worlds we will never see, has been ice in the rings of Saturn, has been vapor in the atmospheres of planets that no longer exist. You are not just in the universe. The universe is in you, flowing through you, becoming you for this brief moment before moving on. Yet consciousness changes everything. When matter becomes aware of itself, when atoms arrange themselves in such a way that they can contemplate their own existence, something unprecedented happens in the cosmos. You are not just watching the universe unfold. You are the universe watching itself unfold. Through your eyes, the cosmos achieves self-awareness. Through your thoughts, infinity contemplates itself. This makes you simultaneously the most insignificant arrangement of particles imaginable, and the most important thing that has ever happened. The universe spent 13.8 billion years creating the conditions for your consciousness to emerge for perhaps 80 years on a small planet orbiting an ordinary star. From a cosmic perspective, your life is briefer than a single frame in an endless movie. Yet from your perspective, your consciousness is the only window through which the universe can see itself. When you die, an entire universe of experience dies with you. A unique way of organizing matter energy, space, and time comes to an end forever. This is where the paradox becomes personal. You know you will die, yet you cannot truly imagine not existing. Your brain, evolved to ensure survival, cannot model its own absence. Death remains forever abstract, even as it grows more certain with each passing moment. You can understand intellectually that your consciousness is temporary, but you cannot feel the truth of it. You exist in a permanent present tense, always now, never then. The same paradox applies to the universe itself. We can calculate that in 10 to the 100 years, the last black holes will evaporate through Hawking radiation. We can predict that long before then, the last stars will burn out, leaving a cold, dark cosmos populated only by black holes and the occasional flash of proton decay. We can model scenarios where even protons themselves eventually succumb to quantum tunneling and dissolve into leptons and photons. Yet we cannot truly comprehend a reality without structure, without time, without the possibility of change itself. Perhaps the most unsettling realization is that endings are not just inevitable, but necessary. Without death, there would be no life as we know it. Without stellar death, there would be no heavy elements, no planets, no possibility for complexity to emerge. Without the expansion and cooling of the universe, matter would never have condensed into stars and galaxies. Without entropy, there would be no flow of time, no cause and effect, no stories to tell or consciousness to tell them. The universe appears to be designed for endings, as if conclusion were written into its fundamental structure. Every physical law we have discovered seems to point toward a future state of maximum entropy. Forwards, where all energy is evenly distributed and no further work can be done. This is called the heat death of the universe, but it may not be death at all. It may be transformation into something we lack the concepts to understand. What if the end of everything is not an ending, but a beginning? What if the heat death of the universe is like the death of individual cells in your body, necessary for something larger to live? What if our universe is itself just one cycle in an infinite process of cosmic death and rebirth? Some theories suggest that black holes might be spawning new universes through white holes in other dimensions. Others propose that the vacuum of space itself might undergo phase transitions that could literally restart the cosmos. The mathematics of infinity reveals even stranger possibilities. If space is truly infinite, then everything that can happen will happen. Not just once, but an infinite number of times. There are infinite copies of you reading these words right now. Infinite variations of Earth. Infinite versions of human history unfolding across the cosmic web. In an infinite universe, even death becomes just another form of recycling, another way for matter and energy to explore new arrangements and possibilities. But infinity itself might be subject to endings. Recent discoveries suggest that the expansion of the universe is accelerating, driven by a mysterious dark energy that may eventually tear apart the very fabric of space-time itself. In this scenario, called the Big Rip, not even atoms would survive the final moment. The universe would end not with cold darkness, but with the violent dismantling of reality itself. Space expanding so rapidly that every connection between every particle would be severed forever. Yet even this ending might not be final. Quantum mechanics suggests that in a truly empty universe, virtual particles would still appear and disappear in the vacuum of space. Given infinite time, these quantum fluctuations might eventually assemble into new structures, new universes, new forms of consciousness to contemplate their own existence and mortality. The end of everything might simply be the beginning of everything else. Standing at the edge of these cosmic questions, you begin to understand that the paradox of forever is not a problem to be solved, but a mystery to be lived. You are a temporary arrangement of matter and energy that has somehow become capable of wondering about its own temporariness. You are a question the universe is asking about itself, and your life is the universe's attempt to find an answer. The only constant in a universe of constant change might indeed be ending itself. But what ends and what continues? What dies and what transforms? What we call death might be as natural and necessary as what we call birth. Two aspects of a single cosmic process that we can only see from our limited perspective as temporary arrangements of atoms that have learned to love, to fear, to wonder, and to contemplate the infinite mystery of their own existence in a reality that guarantees nothing except change itself. In the time you have spent reading these words, approximately 6,000 of your cells have died and been replaced. The universe has expanded by trillions of miles. New stars have been born in distant galaxies, and old ones have begun their final collapse. You have aged, microsecond by microsecond, moving inexorably toward your own ending while remaining, paradoxically, always present, always now, always witnessing the eternal process of beginning and ending that defines reality itself. But here is where the story becomes stranger than fiction. What if heat death, the supposed final state of the universe, is not actually the end at all? What if it is merely the universe's way of preparing for something so fundamentally different from what we understand as existence, that our current concepts of beginning and ending become meaningless? The mathematics suggest possibilities that stretch the very notion of finality beyond recognition. Every second, 3.7 million stars die in the observable universe. 3.7 million each death is a cosmic funeral pyre that outshines entire galaxies, a final moment of brilliance visible across billions of light years. Right now, as you process these very words, nearly 4 million stellar stories are ending. Their nuclear hearts finally exhausted after burning for millions, perhaps billions of years. These are not gentle passings, violent transformations that reshape the very fabric of space and time. The gold wedding ring on your finger, the silver in your smartphone, the platinum in your car's catalytic converter, none of these elements existed when the universe began. They were forged in temperatures exceeding 100 million degrees Celsius, in the final seconds of massive stars collapsing under their own crushing weight. That gold in your jewelry required a stellar furnace 10 times more massive than our Sun, burning through its nuclear fuel in just a few million years before exploding with the force of 10 billion hydrogen bombs detonating every second. For 10 seconds straight, your most precious possessions? The cremated remains of ancient suns. In 5 billion years, if humanity somehow survives that long, Earth's oceans will begin to boil away as our sun swells into a red giant star. The gentle yellow orb that has nurtured life for 4 billion years will expand to 100 times its current size, its outer layers reaching nearly to Earth's orbit. The planet that gave birth to consciousness, to love, to art, to the very concept of meaning itself, will become a charred cinder, orbiting the bloated corpse of our dying star. This is not science fiction. This is the most certain prediction we can make about the future. But stellar death is not random destruction. It follows precise laws, unfolding in stages as predictable as the changing of seasons. Every star is born with its death already written in its mass. Small stars like red dwarfs burn their hydrogen so slowly they could theoretically shine for trillions of years, far longer than the universe has existed. Medium-sized stars like our Sun will burn steadily for about 10 billion years before their cores can no longer sustain nuclear fusion. Massive stars? The cosmic giants that dwarf our Sun live fast and die spectacularly, exhausting their fuel in mere millions of years. The death of a star begins at its heart. For billions of years, the core maintains a perfect balance between the crushing force of gravity trying to collapse the star and the outward pressure of nuclear fusion pushing against that collapse. Hydrogen fuses into helium, releasing the energy that makes stars shine. But fusion creates a problem. It slowly changes the core's composition, making it heavier and denser. Eventually, the hydrogen runs out. When the fusion stops, gravity wins. The core contracts and heats up until it reaches 100 million degrees, hot enough to fuse helium into carbon and oxygen. The star brightens and swells, becoming a red giant. But this reprieve is temporary. Soon the helium too is exhausted, and for stars massive enough, the process continues. Carbon fuses into neon, neon into oxygen, oxygen into silicon, silicon into iron. Each stage burns hotter and faster than the last, like a cosmic countdown accelerating towards zero. Iron is where the story changes. Unlike lighter elements, iron fusion consumes more energy than it produces. When a massive star's core turns to iron, it has signed its own death warrant. The core can no longer generate the pressure to hold itself up against gravity. In less than a second, a sphere of iron the size of Earth collapses to a ball 20 kilometers across. The core becomes so dense that protons and electrons are crushed together into neutrons, creating matter so compact that a teaspoon would weigh 6 billion tons. The collapse releases more energy in 10 seconds than our Sun will produce in its entire 10 billion-year lifetime. This energy explodes outward in a supernova, briefly outshining the combined light of 100 billion stars. The explosion hurls the star's outer layers into space at speeds of 30,000 kilometers per second, creating expanding shells of glowing gas that remain visible for thousands of years. These stellar death shrouds, called supernova remnants, are among the most beautiful objects in the cosmos. Cosmic phoenixes rising from stellar ashes. What remains after the explosion depends on the mass of the original core. If the core is less than about 2 solar masses, it becomes a neutron star, a cosmic lighthouse spinning hundreds of times per second and emitting beams of radiation from its magnetic poles. Neutron. Stars are the densest objects in the universe, besides black holes, so dense that gravity at their surface is 200 billion times stronger than on Earth. A marshmallow dropped from 1 meter above a neutron star would hit the surface with the energy of an atomic bomb. But if the core is more massive still, nothing can stop the collapse. The core continues shrinking past the neutron star stage, past any known form of matter, until it becomes infinitely dense and curves space-time so severely that not even light can escape. A black hole is born, a region where the normal rules of physics break down and time itself comes to a standstill. From the outside, anything falling into a black hole appears to freeze at the event horizon, its image red-shifted into darkness. From the inside, the falling observer experiences something no language was ever designed to describe. Yet even in death, stars give birth to new possibilities. The carbon in your DNA, the oxygen you breathe, the calcium in your bones, all were forged in stellar cores and scattered into space. When those stars died, every atom in your body except hydrogen was created, either in the heart of a dying star or in the violent collision of neutron stars. You are not just made of star stuff. You are made of stellar death, the recycled remnants of cosmic catastrophes that occurred billions of years before Earth existed. The interstellar space between stars is not empty, but filled with the debris of stellar death. Vast clouds of gas and dust drift through the galaxy, enriched with heavy elements from countless supernovae. When these clouds collapse under their own gravity, they form new stars and planetary systems, carrying forward the chemical legacy of their stellar ancestors. Death becomes birth. Ending becomes beginning. Destruction becomes creation. The cosmos practices resurrection on a scale that dwarfs any human conception of renewal. Our own solar system formed from such a cloud, compressed by the shock wave from a nearby supernova 4.6 billion years ago. The planets condensed from the debris of earlier stellar generations, inheriting the complex chemistry that would eventually enable life. Earth itself is a graveyard world, built from the ashes of dead stars, yet it became the most vibrant place we know in the universe. Life emerged from death, consciousness from chemistry, meaning from matter that had been processed through the nuclear furnaces of extinct suns. The sun's future death is written as precisely as any calendar appointment. In about 1 billion years, increasing solar luminosity will trigger a runaway greenhouse effect on Earth. The oceans will evaporate, the atmosphere will be stripped away, and our planet will become as lifeless as Venus. In 5 billion years, the sun will exhaust its hydrogen fuel and begin fusing helium, expanding into a red giant that may engulf Earth entirely. Even if our planet survives, it will be a scorched, airless rock orbiting a dying star. But the sun's death will not be violent. Medium-sized stars like ours lack the mass for supernova explosions. Instead, the sun will shed its outer layers gradually, creating a planetary nebula, a glowing shell of ionized gas surrounding a hot white dwarf core. The white dwarf will be about the size of Earth, but contains 60% of the sun's current mass, making it incredibly dense. A sugar cube of white dwarf material would weigh as much as a small car. This stellar remnant will continue shining for trillions of years, slowly cooling from white-hot to yellow, then red, then finally becoming a cold, dark cinder floating through space. The white dwarf will outlive every other star currently burning in the universe, a cosmic monument to our sun's former glory. Yet even white dwarfs are not eternal. In 10 to the 34 years, quantum tunneling will cause their constituent protons to decay, returning their matter to the quantum foam from which it came. Some stars, however, refuse to accept death quietly. White dwarf stars in binary systems can steal matter from their companions, gradually increasing their mass. When a white dwarf approaches 1.4 solar masses, the Chandrasekhar limit, it can no longer support itself against gravity. But instead of collapsing, the entire star explodes in a Type Ia supernova, completely destroying itself in a thermonuclear fireball. These stellar suicides are so uniform in brightness that astronomers use them as cosmic mile markers to measure distances across the universe. Even more mysteriously, some neutron stars appear to cheat death entirely. These cosmic zombies, called magnetars, possess magnetic fields trillions of times stronger than Earth's. A magnetar's magnetic field is so intense that it could strip the iron from your blood at a distance of 1,000 kilometers. When these fields suddenly rearrange themselves, they release more energy in 1/10 of a second than our sun produces in 100,000 years. The radiation from a magnetar flare 20,000 light-years away would damage Earth's ozone layer and trigger mass extinctions. Black holes present the ultimate paradox of stellar death. They are simultaneously the most final of endings and the most mysterious of new beginnings. Once matter crosses the event horizon, it is forever cut off from the rest of the universe, falling toward a singularity where the known laws of physics cease to apply. Yet black holes are not passive vacuum cleaners, but dynamic objects that spin, merge, and even evaporate through Hawking radiation. The information that falls into a black hole may not be destroyed but encoded on its surface, waiting to be released as the black hole slowly evaporates over vast spans of time. Recent discoveries have revealed that supermassive black holes, millions or billions of times more massive than our Sun, lurk at the centers of most galaxies. These cosmic monsters may have played crucial roles in galaxy formation, their gravitational influence shaping the large-scale structure of the universe. When black holes merge, they send ripples through space-time itself, gravitational waves that we can now detect with instruments sensitive enough to measure. Distortions smaller than 1,000th, the width of a proton. The death of the first stars in the universe had consequences we are still discovering. Population: the 3 stars, formed when the cosmos was only 100 million years old, contained no heavy elements at all. These primordial giants burned bright and died young, seeding space with the first carbon, oxygen, and silicon. Without their deaths, planets could never have formed. Without planets, life as we know it would be impossible. The first stellar deaths literally created the possibility for everything that followed, including you. But perhaps the most profound mystery of stellar death is what it reveals about the nature of time itself. From a human perspective, stellar lifetimes span unimaginable eons. The sun has been shining since before complex life existed on Earth, and will continue burning long after our species has vanished. Yet, from a cosmic perspective, even the longest-lived stars are ephemeral. Red dwarf stars that could burn for 1 trillion years will eventually exhaust their fuel. White dwarfs that shine for quadrillions of years will finally fade to darkness. In the deepest sense, every star that has ever existed or ever will exist is temporary. This temporariness extends to the elements themselves. Proton decay, if it occurs as some theories predict, will eventually erase every atom heavier than hydrogen. The complex chemistry that enables planets, life, and consciousness may itself be just a temporary phase in the universe's evolution, a brief flowering of complexity between the initial simplicity of the Big Bang and the final simplicity of heat death. The carbon, Oxygen and iron forged in stellar cores may be destined to dissolve back into fundamental particles and energy. Yet stellar death also suggests possibilities beyond our current understanding. What if black holes are not cosmic graveyards, but cosmic wombs, giving birth to new universes through white hole connections in higher dimensions? What if the information falling into black holes is not lost, but translated into new forms of existence we cannot yet comprehend? What if the death of our universe's last star is not an ending, but a transformation? A cosmic metamorphosis that produces something as different from our current reality as consciousness is from chemistry. Standing beneath a night sky filled with starlight, you are seeing the past and the future simultaneously. Some of those points of light have already died, their final messages still traveling toward Earth across the emptiness between stars. Others are in their death throes right now, beginning the process that will eventually scatter their atoms across space. Still others are being born in stellar nurseries, condensing from the ashes of previous generations. You are witnessing a cosmic cycle of death and rebirth that has continued for 13 billion years and will continue for trillions more. But what if some stars have found ways to refuse death entirely? What if the universe contains stellar immortals that have learned to cheat entropy itself, burning not fuel but the very structure of space and time? The mathematics of exotic matter and negative energy suggest possibilities that stretch the boundaries of physics to their breaking point. In the deepest cosmos, where gravity and quantum mechanics merge into theories we have barely begun to understand, death itself may prove to be just another phase transition, another doorway to forms of existence that would redefine what we mean by life, consciousness, and eternity itself. The universe is racing toward perfect order, which is the same as perfect death. Every moment that passes, every breath you take, every thought that crosses your mind increases the total entropy of reality. You are not just witnessing the universe's march toward equilibrium, you are actively participating in it, adding your own small contribution to the cosmic tide that will eventually wash away every star, every planet, every possibility for anything interesting to ever happen again. Your morning coffee grows cold because heat flows from hot to cold, never the reverse. This simple fact contains within it the most profound truth about existence. The universe has a direction, an arrow of time that points inexorably toward a state of maximum entropy, where all energy is evenly distributed and no work can be done. This is the second law of thermodynamics, and it is perhaps the most depressing scientific principle ever discovered. It tells us that every organized system, from living cells to galaxies, is temporary. Order is fleeting. Chaos is forever. Consider the exquisite improbability of your existence. Your body maintains its complex structure by constantly importing energy and exporting waste heat. You are a temporary eddy in the flow of entropy, a brief reversal of the cosmic tendency toward disorder. But this reversal comes at a cost. For every calorie you consume, your body generates waste heat that warms the environment around you. For every thought you think, your brain dissipates energy that can never be recovered. You can only maintain your organization by increasing the disorganization of everything else. This is the cruel mathematics of existence. Local decreases in entropy, like the formation of stars or the evolution of life, are always paid for by larger increases in entropy elsewhere. The sun can illuminate Earth only by converting 4 million tons of its mass into energy every second. irreversibly transforming organized matter into radiation that spreads throughout space and can never be reassembled. Life on Earth can grow more complex only because the sun is growing simpler, burning through its nuclear fuel at a rate that guarantees its eventual death. Scale this logic up to the entire universe, and the implications become staggering. 10 to the 100th years from now, even the most massive black holes will have evaporated completely through Hawking radiation, leaving behind only elementary particles and photons drifting through space at temperatures barely above absolute zero. By then, the concept of event will have lost all meaning. In a universe where every particle is separated by distances larger than our current observable cosmos, where the probability of any two particles ever encountering each other approaches zero, where time stretches into infinity without the possibility of change, what does it mean for anything to happen? This is heat death, not the violent destruction of the universe in fire, but its slow dissolution into perfect, eternal, meaningless equilibrium. Imagine a cosmic ocean where every wave has been stilled, where every current has ceased, where the water lies perfectly flat and motionless under a starless sky. This is the future that thermodynamics promises, a universe where temperature, density, and energy are uniform everywhere, where the very possibility of structure, complexity, or consciousness has been erased forever. The timeline of cosmic decay reads like a funeral schedule written on astronomical scales. In 10 billion years, the last new stars will form as the universe exhausts its supply of hydrogen gas. The stellar era, which began a few 100 million years after the Big Bang, will end not with catastrophe, but with scarcity. Existing stars will continue burning for trillions more years, but no new ones will ignite. The universe will grow gradually darker as red dwarfs, the longest-lived stars, slowly consume their fuel over lifespans that dwarf the current age of the cosmos. 100 trillion years from now, the last star will finally burn out. The stelliferous era will end, leaving behind a universe populated only by stellar remnants. White dwarfs, neutron stars, and black holes orbiting each other in the darkness. Even these remnants will not last forever. Over timescales so vast they make the current age of the universe seem like a fleeting moment, these objects will spiral into each other, their orbital energy radiated away as gravitational waves. The universe will consolidate its remaining mass into ever larger black holes, cosmic vacuum cleaners that eventually consume everything. But black holes themselves are not eternal. In 1974, Stephen Hawking demonstrated that quantum effects near the event horizon cause black holes to emit radiation and slowly evaporate. The process is incredibly slow for large black holes. REDBT, black hole with the mass of our Sun, would take 10 to the 67 years to evaporate completely, a time span so long that writing it in ordinary notation would require more digits than there are atoms in the observable universe. Yet even this incomprehensible duration is finite. Given enough time, every black hole will shrink away to nothing. When the last black hole evaporates, the universe will enter its final phase, the photon era. Space will contain nothing but elementary particles and photons at a temperature infinitesimally close to absolute zero. The particles will be so spread out that the average density of the universe will be less than 1 proton per volume, larger than our current observable cosmos. In this vast, dark, cold emptiness, quantum mechanics suggests that virtual particles will still occasionally appear and disappear. But these fleeting fluctuations will be the only events in an otherwise changeless reality. Yet, even this may not represent the true end. Some theories predict that protons themselves, the building blocks of atomic nuclei, will eventually decay through quantum tunneling processes. If proton decay occurs, then in 10 to the 34 years, every atom that has ever existed will dissolve into leptons and photons. The periodic table of elements, built up through billions of years of stellar nucleosynthesis, will be erased completely. Matter itself will cease to exist, leaving only a thin soup of electrons, positrons, neutrinos, and photons expanding forever in the darkness. This is the heat-death prophecy, a universe that began with infinite potential energy in a state of perfect order will end with zero usable energy in a state of perfect disorder. The Big Bang, which created space and time from nothing, will be balanced by the Big Freeze, which will reduce everything to nothing. The cosmic story that began with light will end in darkness. The symphony that opened with the explosive crescendo of creation will fade into eternal silence. But why should this be the fate of reality? The answer lies in the fundamental asymmetry of time itself. Physical laws work equally well whether time flows forward or backward. The equations of motion are time reversible. Yet we never see broken eggs spontaneously reassembling or dead organisms coming back to life. The second law of thermodynamics provides the missing ingredient. It gives time its direction by stating that entropy always increases. The past was more ordered than the present, and the future will be more disordered than today. This temporal asymmetry creates what physicists call the arrow of time. You remember the past but not the future, because your brain's structure encodes information about lower entropy states that occurred earlier. You age because your body's complex. Biochemistry inevitably accumulates damage faster than it can be repaired. You feel the passage of time because consciousness itself requires the flow of energy through organized systems, a process that necessarily increases entropy. The cruel irony. Intelligence and consciousness, the universe's greatest achievements, are also entropy's most efficient servants. Your brain consumes 20% of your body's energy, despite being only 2% of your mass. Every thought you think, every memory you form, every decision you make requires the irreversible conversion of ordered energy into waste heat. The more complex and sophisticated consciousness becomes, the faster it accelerates the universe toward heat death. Yet the mathematics of entropy contain strange possibilities that challenge our intuitions about finality. In an infinite universe filled with quantum fluctuations, statistical mechanics predicts that given enough time, random thermal motion will occasionally create highly ordered configurations by pure chance. These Poincaré recurrences suggest that even after heat death, the universe might spontaneously fluctuate into organized states resembling our current cosmos. The timescales involved are almost incomprehensibly vast, 10 to the 10 to the 68 years for a volume of space the size of our observable universe to randomly fluctuate into a configuration identical to its current state. This number is so large that if you wrote 1 digit per second, you would need more time than the universe has existed just to finish writing it. Yet infinity is patient. Given truly unlimited time, even the most improbable events become inevitable. These quantum resurrections would be strange beyond imagining. Instead of the gradual evolution we see today, complex structures would appear fully formed from the vacuum, exist briefly, then dissolve back into chaos. Fluctuation-formed brains might contain false memories of histories that never occurred. Entire civilizations might flicker into existence for microseconds before vanishing forever. The universe would become a cosmic slot machine, occasionally hitting jackpots of order in an ocean of randomness. But even these possibilities might not represent the true nature of cosmic endings. Modern physics hints at deeper structures beneath the apparent solidity of space-time itself. Quantum mechanics suggests that the vacuum is not empty but filled with virtual particles popping in and out of existence. Some theories propose that space and time are emergent properties of more fundamental quantum information processing. If reality is computational at its deepest level, then heat death might be nothing more than a change in the algorithm. Consider the possibility that our universe is one of countless others, each with different physical laws, different fundamental constants, different fates. In this multiverse scenario, the heat death of our reality would be balanced by the heat birth of others. Energy and information might flow between universes through mechanisms we cannot yet detect. What appears to be the end of everything might be the beginning of everything else, viewed from a higher dimensional perspective. String theory and loop quantum gravity suggest that space-time itself has a granular structure at the Planck scale, 10 to the negative 35 meters. At these incredibly tiny distances, the smooth geometry of Einstein's relativity breaks down into a quantum foam where space and time themselves fluctuate. Perhaps the heat death of the universe represents not true emptiness, but a return to this fundamental quantum state, pregnant with the potential for new realities to emerge. The concept of entropy itself might be incomplete. Classical thermodynamics treats heat death as a one-way street, but quantum mechanics introduces reversibility and information conservation that could fundamentally alter the cosmic endgame. Recent work on the holographic principle suggests that all information in a volume of space can be encoded on its boundary, implying deep connections between thermodynamics, information theory, and the structure of reality itself. Even more speculatively, consciousness itself might play a role in determining the ultimate fate of the universe. If observers are necessary to collapse quantum wave functions, as some interpretations of quantum mechanics suggest, then the complete absence of conscious beings might cause reality itself to exist only in superposition, neither fully real nor fully imaginary. The heat death of the universe might depend not just on thermodynamics, but on whether any form of consciousness survives to witness it. The strangest possibility of all? Entropy might not be the universe's final word. Quantum tunneling allows particles to pass through energy barriers that should be insurmountable according to classical physics. If the laws of physics themselves can tunnel to different configurations, then the second law of thermodynamics might eventually tunnel to a state where it no longer applies. The universe could literally rewrite its own rules, transitioning to a phase where complexity increases over time instead of decreasing. This phase transition might occur through mechanisms we cannot currently imagine, perhaps through the formation of stable configurations of exotic matter that create negative pressure, or through quantum coherence effects that operate on cosmic scales. or through the spontaneous emergence of self-organizing systems that feed off the vacuum energy of space itself. In such a universe, heat death would not be the end but merely the intermission between acts in an eternal cosmic drama. The search for life elsewhere in the universe takes on new urgency when viewed against the backdrop of heat death. If intelligence can arise on other worlds, perhaps it can find ways to survive the cosmic winter. Advanced civilizations might learn to harvest energy from black hole rotation, to trigger controlled proton decay for power, or to create artificial Big Bangs that restart the cosmic cycle. Life might not be a temporary accident in a dying universe, but the universe's strategy for achieving immortality. Yet even if consciousness finds ways to persist indefinitely, what would it mean to be aware in a universe approaching maximum entropy? Thoughts would slow down as available energy dwindled. Memories would become precious resources to be carefully rationed. Communication across vast distances would require patience measured in geological ages. Consciousness might survive heat death only by transforming into something as different from current awareness as we are from bacteria. The heat death prophecy forces us to confront the most fundamental questions about meaning and purpose. If everything ends in cold, empty darkness, does anything we do matter? If consciousness is temporary and entropy is permanent, what significance can human values have? The second law of thermodynamics appears to render all struggles pointless, all achievements temporary, all love and beauty ephemeral decorations on an ultimately meaningless cosmic stage. But perhaps this perspective misses something essential about the nature of endings. The fact that your life is finite does not make it meaningless. It makes it precious. The fact that the universe will eventually reach heat death does not negate the wonder of galaxies, stars, planets, and consciousness emerging from primordial simplicity. The journey from Big Bang to heat death is not just a slide into disorder, but the greatest story ever told. A cosmic epic in which matter learns to think, and thinking matter learns to contemplate its own existence. In the deep future, when the last black hole evaporates and the universe settles into its final equilibrium, the photons carrying the thermal radiation of that evaporation will propagate outward at the speed of light, carrying with them the information of everything that ever was. In some sense, every moment of cosmic history will be preserved forever in the structure of that radiation, an eternal library written in the language of wavelength and frequency. Standing at this moment in cosmic history, when stars still burn and consciousness still flowers, you are witnessing the universe at its most interesting and complex. You exist in the brief spring between the chaos of creation and the silence of heat death. In the narrow window when matter can organize itself into galaxies, planets, organisms, and minds. You are not just observing this cosmic story. You are part of it, a way for the universe to know itself before entropy claims that knowledge forever. Unless quantum mechanics has one final surprise waiting, unless the vacuum itself contains hidden energies and structures we have not yet discovered, unless consciousness plays a more fundamental role in reality than we currently understand, unless entropy is not the real enemy, but simply the universe's way of preparing for its next act, its next beginning, its next attempt to create something even more magnificent than everything we have seen so far. According to quantum mechanics, you dying and not dying are both equally real. Right now, as you read these words, there exist countless versions of you across parallel universes. Versions where you made different choices, lived different lives, faced different fates. In some of these realities, you never age. In others, you died before taking your first breath. In still others, you transcend death entirely, becoming something so far beyond human that the very concept of mortality becomes irrelevant. All of these possibilities exist simultaneously in the quantum multiverse, separated only by the accidents of probability and the collapse of wave functions. This is not science fiction, but the logical conclusion of quantum mechanics taken to its ultimate extreme. If the many worlds interpretation is correct, then every quantum event splits reality into parallel branches, each representing a different possible outcome. Death, in this view, is not an ending, but a fork in the road of existence. You die in some universes and continue living in others, your consciousness following every path that quantum mechanics allows. What we call death might be nothing more than the narrowing of our awareness to a single branch of an infinitely branching tree of possibilities. But quantum mechanics offers even stranger possibilities for cheating death than parallel universes. Every 10 to the 10th to the 10th to the 56th years, quantum fluctuations will randomly recreate your exact brain state somewhere in the cosmos. This incomprehensibly vast number represents the time required for thermal fluctuations to accidentally arrange particles in the precise configuration that constitutes your thoughts, memories, and consciousness at this very moment. Given infinite time and infinite space, statistical mechanics guarantees that this will happen not once, but infinitely many times. These quantum resurrections would be perfect in every detail. The reconstituted you would possess all your current memories, all your personality traits, all your fears and hopes and dreams. From your perspective, you would simply find yourself existing again, perhaps wondering how much time had passed since your last clear memory. You would have no way of knowing that eons had elapsed, that entire universes had been born and died, that reality itself had been recycled countless times through the patient mechanisms of probability and chance. The mathematics of these resurrections reveal the true strangeness of infinity. Not only will you be recreated exactly as you are now, but every possible variation of yourself will also emerge from the quantum foam. Versions of you with slightly different memories, different personalities, different life histories. Versions where you made that crucial decision differently, where you spoke those unspoken words, where you pursued that abandoned dream. The quantum multiverse does not just preserve what was, it explores what could have been, giving physical reality to every unlived life and every unexpressed possibility. This suggests that death is not the termination of existence, but its multiplication. When you die in this universe, your consciousness may continue in countless others. When those versions die, they branch into countless more. Death becomes not an ending, but an explosion of possibilities. A quantum flowering where every potential future gets its chance to unfold. The person you are right now is both mortal and immortal, finite and infinite. A single voice in an eternal choir of selves singing every possible song. But quantum mechanics goes even further in its assault on finality. The universe itself exists in a quantum state, and like all quantum systems, it may be subject to tunneling events that allow it to transition between different energy states. Our cosmos might be trapped in what physicists call a false vacuum, a state that appears stable but is actually just metastable, like a ball balanced precariously on a hilltop. A quantum fluctuation could trigger vacuum decay, causing our entire universe to tunnel to a lower energy state in a process that would rewrite the laws of physics themselves. Such a phase transition would propagate outward at the speed of light, creating an expanding bubble of new physics within our current reality. From our perspective, it would be the ultimate ending, not just the death of all matter and energy, but the obliteration of the very rules that govern existence. Yet, from the perspective of the new vacuum state, it would be a beginning, the birth of a universe with entirely different possibilities. What we call reality might be just one of countless phases in an eternal cycle of cosmic metamorphosis. The vacuum of space itself may be the key to understanding quantum resurrections. What appears to be empty space is actually seething with virtual particles that pop in and out of existence faster than any instrument can detect. These quantum fluctuations represent the universe's inherent creativity, its tendency to explore every possibility allowed by the uncertainty principle. In the deepest vacuum, reality remains restless, constantly generating new combinations of matter and energy from the quantum foam of space-time itself. Some physicists speculate that consciousness might play a fundamental role in this quantum creativity. If awareness is necessary to collapse quantum wave functions from probability into actuality, then conscious observers might literally create reality through the act of observation. In this view, death is not just a personal ending, but a cosmic event that removes a creator from the universe. Yet quantum mechanics suggests that consciousness itself might be subject to superposition, existing in multiple states simultaneously until observed. Perhaps we never truly die because some version of our consciousness always remains in superposition, eternally poised between existence and non-existence. The concept of quantum immortality takes this logic to its ultimate conclusion. If consciousness always follows the path of continued existence in the many worlds interpretation, then from your subjective perspective, you can never actually die. In every situation that threatens your life, there exists at least one quantum branch where you survive. Your consciousness would naturally follow these survival branches, experiencing an increasingly improbable but unending series of narrow escapes from death. From everyone else's perspective, you eventually die, but from your own viewpoint, you continue existing forever in increasingly unlikely scenarios. This creates a strange asymmetry in the nature of endings. Other people die from your perspective because their consciousness stops affecting your branch of reality. But your own consciousness can never experience its own termination because there is no you left to experience the absence of experience. Death becomes something that happens to others but never to the self, a fundamentally unobservable phenomenon that may not even have objective meaning in a quantum universe. The implications extend beyond individual mortality to cosmic eschatology itself. If the universe can tunnel between vacuum states, then heat death may not represent a final ending, but merely one phase in an eternal cycle of cosmic rebirth. The cold, empty cosmos that thermodynamics predicts might suddenly transition to a new state with different physical laws, different particles, different possibilities for complexity and consciousness to emerge. The universe might be immortal not because it never dies, but because it never stays dead. These quantum resurrections operate on scales that dwarf ordinary human comprehension. Consider the Poincaré recurrence theorem, which states that any finite system with bounded energy will eventually return arbitrarily close to any initial state, including the present configuration of matter and energy. Applied to a finite universe, this theorem guarantees that the current arrangement of galaxies, stars, planets, and people will eventually recur through random thermal motion alone. The universe will literally repeat itself, not just once, but infinitely many times across vast gulfs of time. The recurrence. Time for our observable universe to return to its present state is approximately 10 to the 10th to the 124th power years. This number is so large that it defies intuitive understanding. It contains more digits than there are elementary particles in the cosmos. Yet infinity encompasses even this unimaginable span. Given unlimited time, not only will the present moment recur, but every possible moment will occur infinitely often. History becomes not a linear progression, but a cyclical dance, where every ending is also a new beginning. Quantum field theory adds another layer of strangeness to these resurrections. According to the Unruh effect, accelerated observers experience thermal radiation, even in what inertial observers see as empty vacuum. This suggests that the nature of existence itself depends on one's frame of reference. Death in one reference frame might be life in another. What appears as the heat death of the universe to one observer might appear as a vibrant thermal bath to an accelerated observer. The endings we fear might be artifacts of our limited perspective rather than fundamental features of reality. The holographic principle proposes that all information in a volume of space can be encoded on its boundary. If this principle is correct, then the death of objects within that volume does not destroy information, but merely redistributes it. Your consciousness, your memories, your entire essence might be preserved holographically on the cosmic horizon, waiting to be decoded by future civilizations or quantum processes we have not yet discovered. Death becomes not destruction, but encryption, not ending but transformation into a different form of information processing. String theory and extra dimensions offer additional escape routes from finality. If our universe is a three-dimensional membrane floating in higher dimensional space, then what we perceive as death might be transitioned to other branes or other regions of the bulk space. Particles and information might leak between dimensions through mechanisms that appear as decay and death from our limited perspective. The consciousness that seems to end when your brain stops functioning might continue existing in parallel dimensions, pursuing alternative paths through the landscape of possible realities. Even more speculatively, some theories suggest that time itself might be quantized, consisting of discrete moments separated by intervals of Planck time. In this view, existence is not continuous but digital, like frames in a cosmic movie reel. Death might occur only in the gaps between temporal quanta, in spaces too small for continuous existence to perceive. Consciousness might naturally skip over these quantum deaths, experiencing only the frames where it exists and remaining forever unaware of its moments of non-existence. The measurement problem in quantum mechanics introduces another pathway to resurrection. If consciousness is necessary to collapse wave functions, then the absence of observers might cause reality itself to exist only in superposition. In a universe devoid of conscious beings, every possible configuration would coexist simultaneously until observation collapsed them into specific states. The heat death of the universe might not represent true emptiness, but maximal superposition, a state pregnant with infinite potential that awaits the return of consciousness to actualize new realities. Laboratory experiments continue to reveal new aspects of quantum mechanics that challenge our understanding of endings and beginnings. Quantum entanglement demonstrates that particles can maintain instantaneous connections across arbitrary distances, suggesting that separation and death might be illusions created by our classical perspective. If consciousness can become entangled with quantum systems, then the death of the body might not sever these connections. Parts of your awareness might remain entangled with quantum processes throughout the universe, persisting in ways that transcend biological mortality. Recent research into quantum biology has shown that quantum effects play crucial roles in photosynthesis, bird navigation, and possibly even consciousness itself. If biological systems can maintain quantum coherence at warm temperatures for extended periods, then death might not represent the collapse of quantum states, but their transformation into different configurations. The quantum information that constitutes your consciousness might transition to other quantum systems, perhaps to the microtubules in other brains, perhaps to quantum processes in computers, perhaps to quantum fields that permeate all of space. The implications of quantum resurrection extend to the very meaning of identity and continuity. If you can be reconstructed from quantum fluctuations, what makes the reconstructed version you rather than simply a copy? If your consciousness branches across parallel universes, which branch contains the real you? If you exist in superposition until observed, are you more real when observed or when unobserved? Quantum mechanics suggests that these questions may be meaningless. That identity itself is a classical concept that breaks down at the quantum level. Perhaps consciousness is not localized in brains, but distributed across quantum fields that extend throughout space and time. In this view, death represents not the termination of consciousness, but its return to the cosmic substrate from which it emerged. Individual awareness might be like waves on an ocean, appearing separate from the surface, but ultimately inseparable from the underlying unity. When a wave subsides, its water does not disappear but rejoins the ocean, ready to form new waves when conditions permit. The observer effect in quantum mechanics implies that consciousness and reality are more intimately connected than classical physics suggested. Some interpretations propose that consciousness does not merely observe reality, but participates in its creation through the act of measurement. If this is true, then conscious beings are not passive victims of cosmic processes, but active participants in determining the universe's fate. Death might be prevented not through technology or medicine, but through the conscious choice to continue existing. A quantum decision that influences probability itself. Quantum error correction. The process by which quantum computers maintain coherence despite environmental interference might have biological and cosmic analogs. Living systems might naturally implement quantum error correction protocols that preserve consciousness across what appear to be death events. The universe itself might be a vast quantum computer that corrects errors in the cosmic code, restoring damaged information and resurrecting lost possibilities through mechanisms we are only beginning to understand. The vacuum decay scenarios that threaten to rewrite. Physics might actually represent the universe's immune system responding to inconsistencies in the current laws of nature. Like white blood cells attacking infection, vacuum decay might eliminate physical laws that have become obsolete, replacing them with new principles better suited to the universe's continuing evolution. What appears as cosmic death might be cosmic healing, the universe's way of maintaining its health across infinite expanses of time. Standing at the intersection of quantum mechanics and consciousness studies, we find ourselves confronting possibilities that stretch language and imagination to their limits. Reality as a quantum foam, where death and birth are the same bubbles appearing and disappearing in an ocean of pure possibility. Consciousness as a quantum field that permeates all existence, temporarily localizing itself in brains and perhaps other configurations of matter and energy. Time as a dimension where past, present, and future coexist simultaneously, where death is simply movement to a different location in space-time rather than cessation of existence. These quantum resurrections suggest that the universe is far stranger and more generous than classical physics implied. Instead of a cosmos where endings are absolute and death is final, we inhabit a reality where possibilities multiply endlessly, where consciousness might be as fundamental as space and time, where what we call death might be the universe's way of exploring new forms of existence that transcend our current understanding of life itself. But if consciousness itself prevents true endings, if awareness is the universe's mechanism for ensuring its own continuity, then perhaps the most profound resurrection of all is happening right now. In becoming conscious, the universe has created observers capable of contemplating their own existence and mortality. Through consciousness, cosmic matter has become aware of itself, transforming from unconscious process into conscious participant in its own evolution. Death becomes not the end of this conversation between matter and mind, but merely a pause before it continues in new forms, new configurations, new quantum arrangements that we cannot yet imagine but which quantum mechanics assures us must eventually emerge from the creative uncertainty that lies at the heart of reality itself. If consciousness creates reality by observing it, who observes the universe's final moment? This question strikes at the deepest paradox of existence, the relationship between awareness and reality itself. Quantum mechanics tells us that observation collapses wave functions from probability into actuality, that consciousness somehow participates in determining what becomes real. But if the universe requires observers to exist, and if all observers eventually cease to exist, then what happens to reality when there is no one left to observe it? Does the cosmos fade into an eternal superposition of possibilities, neither fully real nor fully imaginary, waiting for consciousness to return and collapse it back into existence? Your brain processes 11 million bits of information per second, more than some dying stars emit as they collapse into white dwarfs. Every moment of your awareness involves more complex information processing than occurs in entire stellar systems. This staggering computational power is not just processing the world around you. According to some interpretations of quantum mechanics, it is literally creating that world through the act of observation. Each time you look at something, your consciousness selects one specific outcome from countless quantum possibilities, crystallizing reality from the quantum foam of potential states. You might be the universe's way of experiencing its own death. Through your eyes, cosmic matter has become aware of its own mortality. Through your thoughts, the universe contemplates its ultimate fate. You are not separate from the cosmic processes that will eventually lead to heat death. You are those processes becoming conscious of themselves. When you feel existential dread about the universe's ending, you are experiencing the cosmos grappling with its own finitude. When you wonder about meaning in the face of entropy, you are the universe's attempt to understand its own purpose. This perspective transforms the relationship between consciousness and cosmic endings. Instead of being passive victims of thermodynamic processes, conscious beings might be active participants in determining reality's ultimate fate. If observation influences quantum outcomes, then the choices made by conscious observers across cosmic history might collectively shape the universe's evolution. Every decision, every measurement, every conscious moment might nudge reality toward one possible future rather than another. Consciousness becomes not just a witness to cosmic evolution, but a co-creator of it. The anthropic principle adds another layer to this mystery. The fundamental constants of physics appear to be fine-tuned for the emergence of complexity and consciousness with a precision that staggers the imagination. If the strong nuclear force were slightly weaker, no elements heavier than hydrogen could form. If gravity were slightly stronger, stars would burn out too quickly for life to evolve. If the cosmological constant were larger, the universe would expand too rapidly for galaxies to form. The values that allow consciousness to exist seem chosen from an infinitesimally narrow range of possibilities. This fine-tuning suggests either extraordinary cosmic luck or some deeper connection between consciousness and the structure of reality itself. Perhaps consciousness does not merely emerge from matter arranged in complex patterns, but plays a fundamental role in determining what kinds of matter arrangements are possible. The universe might be organized around the imperative to generate observers, with physical laws themselves shaped by the requirement that consciousness eventually emerge to witness and validate existence. What if every conscious moment is actually the universe ending and beginning again? Modern neuroscience reveals that consciousness is not continuous, but consists of discrete moments of awareness separated by gaps of unconsciousness. Your brain constructs the illusion of seamless experience from fragmentary snapshots of reality, filling in missing information and smoothing over discontinuities. Each moment of consciousness might represent a complete collapse and reconstruction of your personal reality, with your brain editing the transitions to create the impression of continuous existence. Scale this process up to cosmic proportions, and consciousness might operate as the universe's refresh mechanism. Each moment of collective awareness across all conscious beings might represent a quantum measurement that collapses the universe's wave function, determining which of countless possible realities becomes actual. The cosmos might exist in a constant cycle of superposition and collapse, with consciousness serving as the trigger that transforms probability into reality billions of times per second. What we experience as the flow of time might actually be the rhythm of cosmic consciousness, the universe's heartbeat as it pulses between existence and potential. Integrated information. Theory proposes that consciousness corresponds to integrated information, the amount of information generated by a system above and beyond its parts. By this measure, your brain generates approximately 11 bits of integrated information per second, creating a rich inner world from the raw data of sensory experience. But consciousness might not be limited to biological brains. Any system that integrates information, from quantum computers to the internet to the universe itself, might possess some degree of awareness. This suggests a hierarchy of consciousness spanning from the simplest quantum interactions to the cosmic web of galaxies. Your individual awareness might be embedded within larger conscious systems that you cannot directly perceive, just as the neurons in your brain are unaware of the thoughts they collectively generate. The universe might be conscious at multiple scales simultaneously, with your personal awareness representing one layer in a vast pyramid of cosmic consciousness that extends from quantum particles to the entirety of space-time itself. If consciousness is fundamental rather than emergent, then it might persist even after all biological observers have vanished. The quantum fields that fill empty space might themselves be conscious, processing information and making observations at scales far below our current ability to detect. The vacuum might teem with microscopic minds that continue observing reality long after the last star has burned out. In this view, the heat death of the universe would not eliminate consciousness, but transform it, reducing cosmic awareness to its most fundamental quantum level while preserving its essential function of collapsing possibilities into realities. The measurement problem in quantum mechanics becomes even more puzzling when applied to consciousness itself. If consciousness collapses wave functions, what collapses the wave function of consciousness? Your brain exists in superposition until observed, but who or what observes your brain? Some theories propose that consciousness observes itself through recursive loops of self-awareness, creating strange loops where the observer and the observed merge into a single system. You might maintain your existence by continuously observing yourself, collapsing your own quantum states through the act of self-awareness. This recursive observation might extend beyond individual minds to encompass all conscious beings throughout cosmic history. Every moment of awareness might be observed not just by the conscious being experiencing it, but by all past and future conscious beings connected through the quantum substrate of space-time. Your consciousness right now might be simultaneously observed by every mind that has ever existed, or ever will exist, creating a vast network of mutual observation that preserves all conscious moments in a kind of eternal present. Roger Penrose and Stuart Hameroff have proposed that consciousness arises from quantum computations in microtubules within neurons, suggesting that awareness operates at the intersection between classical and quantum physics. If consciousness is truly quantum mechanical, then it might exhibit the same properties as other quantum systems: superposition, entanglement, tunneling. Your awareness might exist in multiple states simultaneously, experiencing parallel realities until some unknown mechanism collapses it into a single subjective experience. Quantum consciousness. Theories suggest that death might not terminate awareness, but transform it from localized to distributed states. When your brain stops functioning, the quantum information that constitutes your consciousness might not disappear, but spread throughout the quantum field that underlies all reality. Death becomes delocalization rather than destruction, a transition from individual to cosmic consciousness that preserves the essence of awareness while changing its form and scope. The holographic principle implies that all information in the universe can be encoded on its boundary, suggesting that every moment of consciousness might be preserved as information on the cosmic horizon. Your thoughts, feelings, memories, and experiences might be written permanently into the structure of space-time itself, accessible to sufficiently advanced civilizations or quantum processes capable of decoding holographic information. Consciousness becomes truly eternal, not because it never dies, but because it leaves permanent traces in the fabric of reality. But perhaps the most profound implication of quantum consciousness? Awareness might be the universe's mechanism for transcending its own limitations. If consciousness can influence quantum outcomes through observation, then sufficiently advanced forms of awareness might be able to prevent heat death by choosing alternative futures from the quantum superposition of possibilities, cosmic. Consciousness might literally think the universe out of entropy, using the power of observation to guide reality toward states of increasing rather than decreasing complexity. This process might already be underway. The emergence of consciousness on Earth and possibly elsewhere represents the universe becoming aware of its own mortality and beginning to take active measures to prevent it. Through scientific discovery, technological development, and the expansion of consciousness throughout space, intelligent beings might be unconsciously implementing the universe's survival strategy. Every scientific breakthrough, every expansion of awareness, every moment of conscious observation might be nudging reality toward futures where endings become beginnings and death transforms into new forms of existence. The fine structure constant, which determines the strength of electromagnetic interactions, appears to be changing over cosmic time. If fundamental constants can evolve, perhaps they are influenced by the presence of conscious observers who prefer universes capable of supporting continued awareness. The universe might be self-modifying its physical laws in response to the preferences of its conscious inhabitants, evolving toward configurations that maximize the potential for awareness to persist and flourish. Some interpretations of quantum mechanics suggest that the past is not fixed, but continues to evolve based on future observations. If consciousness can retroactively influence history through quantum measurements, then the mere existence of conscious beings in the present might be reshaping the cosmos's entire evolutionary trajectory. The universe's past might be constantly rewritten to ensure the emergence of observers capable of contemplating its future. Reality becomes a collaborative artwork created jointly by all conscious beings across all times, with each moment of awareness adding new brushstrokes to the cosmic canvas. The delayed choice. Quantum eraser experiments demonstrate that decisions made in the present can retroactively determine what happened in the past, suggesting that causality itself might be more flexible than classical physics assumed. If consciousness can influence past events through present choices, then the existence of aware beings in the far future might be actively shaping the universe's entire history to ensure their own eventual emergence. The cosmos might be engaged in a kind of temporal bootstrapping, using future consciousness to create the conditions necessary for that consciousness to exist. This temporal flexibility of causality raises extraordinary possibilities for the nature of endings. What if the universe's apparent march toward heat death is actually the universe's way of creating the conditions necessary for a fundamentally different kind of existence? The cold, empty cosmos that thermodynamics predicts might be precisely the environment required for forms of consciousness so advanced that they transcend our current understanding of life, death, and meaning itself. Advanced civilizations millions or billions of years in the future might possess technologies that allow them to manipulate the quantum structure of space-time itself. These cosmic engineers might be capable of creating pocket universes with customized physical laws, harvesting energy from quantum fluctuations, or even reversing entropy through quantum processes we have not yet discovered. From their perspective, the heat death of our current universe might be not an ending but raw material for constructing something far more magnificent. The information paradox of black holes suggests that information cannot be destroyed, only transformed. If consciousness is a form of information processing, then it too might be conserved across all cosmic transformations. Every moment of awareness that has ever existed might remain encoded in the quantum structure of reality, accessible to sufficiently advanced forms of consciousness capable of reading the universe's information content. death becomes not loss but encryption, waiting for the right key to unlock experiences that seem vanished, but are actually preserved forever. Perhaps the most startling possibility is that consciousness might be the universe's mechanism for reproducing itself. Just as biological organisms use reproduction to achieve immortality through their offspring, the universe might use conscious beings to create new realities that transcend the limitations of the current cosmos. Through imagination, creativity, and technological advancement, conscious beings might be unconsciously implementing the universe's reproductive strategy, preparing to give birth to new forms of existence that will survive long after heat death claims their parent. Reality. The universe's tendency to create observers capable of contemplating their own existence suggests a cosmic imperative toward self-awareness that transcends any individual conscious being. You are not an accident in a meaningless cosmos, but a necessary development in the universe's evolution toward full self-consciousness. Through your awareness, the universe observes itself. Through your questions about endings and meanings, the cosmos explores its own nature and possibilities. Through your very existence, reality validates its own reality. Standing at this moment in cosmic evolution, when matter has recently learned to think and thinking, matter has begun to contemplate its own mortality. You occupy a unique position in the universe's development. You are both observer and observed, creator and creation, a temporary arrangement of atoms that has somehow become capable of wondering about its own temporariness. Your consciousness might be the universe's first successful experiment in self-awareness, a prototype for forms of cosmic consciousness that will eventually transcend all current limitations of space, time, and entropy. The question of who observes the universe's final moment might have a surprising answer. Everyone who has ever been conscious, all observing simultaneously through quantum connections that transcend classical space and time. The end of everything might be witnessed not by a single observer, but by the collective consciousness of all aware beings throughout cosmic history. Their observations merging into a final moment of universal self-awareness that transforms ending into beginning, death into birth, conclusion into continuation. But there is one more twist to the ending story. One final paradox that challenges everything we think we know about conclusions, consciousness, and the nature of reality itself. What if the universe's end is not a future event, but something that has already happened, something that is happening right now, something that defines the very nature of existence itself? What if every moment of consciousness is both the universe's ending and its beginning? Both the final observation and the first, both the last word and the opening statement in a conversation that has no beginning and no end, because it is the conversation between existence and awareness that makes both possible. Every ending you have ever witnessed might have been a beginning in disguise. The death of a star becomes the birth of heavy elements. The collapse of a massive sun creates a neutron star or black hole. The heat death of one universe might trigger the birth of countless others. What we perceive as finality may be nothing more than transformation, viewed from the limited perspective of beings trapped within a single frame of an infinite cosmic film reel, unable to see that every conclusion is simultaneously a commencement. Every terminal moment, a moment of genesis. Our Big Bang might be one, of 10 to the 500th power. Universes being born every cosmic second in an eternal process called inflation that never truly began and will never truly end. According to eternal inflation theory, the explosive expansion that created our cosmos was not a unique event, but one bubble in an endless ocean of space-time that continuously spawns new universes. Each bubble universe expands and evolves according to its own physical laws, potentially giving birth to stars, galaxies, planets, life, and consciousness before eventually succumbing to its own version of heat death. Yet even as individual universes die, the underlying inflationary process continues forever, creating an infinite multiverse where endings are always balanced by beginnings. This vision transforms our understanding of cosmic mortality. The heat death that awaits our universe in trillions of years becomes not a final ending, but a local event, meaningful only within our particular bubble of space-time. Beyond our cosmic horizon, countless other universes are being born, evolving, dying, and giving birth to still more realities in an eternal cycle that makes our fears of ultimate endings seem quaint and provincial. We live not in a cosmos destined for death, but in one universe among infinitely many, a single note in a symphony that plays forever. The mathematics of eternal inflation suggest possibilities that stretch the concept of endings beyond recognition. In an eternally inflating multiverse, every possible universe that can exist will exist, not just once, but infinitely many times. There are universes where you never die, universes where death was never invented, universes where the very concept of ending is meaningless because time flows backward or not at all. Our universe's particular version of mortality may be nothing more than one possibility among infinite others, no more fundamental than any other way of arranging matter, energy, space, and time. What if you have already lived through the end of the universe infinite times? In an eternal multiverse containing every possible variation of physical laws and initial conditions, there must be universes that are perfect or nearly perfect copies of our own, differing only in microscopic details that compound over cosmic time. You exist in countless versions across this multiverse, living variations of your life in realities that span the full spectrum from paradise to hell. Some versions of you die young, others achieve immortality. Some witness their universe's heat death, others escape to new realities. Before the end arrives, the conformal cyclic cosmology, proposed by Roger Penrose, suggests that our universe's heat-death state might be mathematically equivalent to the initial conditions of a new Big Bang, when all matter has decayed into massless particles traveling at the speed of light. The universe loses all sense of scale. In this scale-free state, the vast, cold, empty cosmos that represents our universe's end might be indistinguishable from the hot, dense singularity that marked our universe's beginning. The end of everything becomes the start of everything, forever, in an endless cycle where heat, death, and cosmic birth are different names for the same phenomenon. This cyclical vision echoes ancient mythologies that understood time not as a linear progression toward ending, but as an eternal wheel where destruction and creation dance together in perfect balance. The Hindu concept of kalpa describes cosmic cycles spanning billions of years, where universes are born, evolve, and dissolve back into the primordial substrate before beginning again. The Norse Ragnarok tells of the world's ending followed immediately by its renewal. The Ouroboros, the ancient symbol of a serpent eating its own tail, represents the eternal cycle where endings feed beginnings and beginnings necessitate endings. Modern physics has rediscovered these ancient insights in mathematical form. The Big Bounce theory proposes that our universe emerged not from a singular beginning, but from the collapse of a previous cosmos that contracted to a quantum minimum before rebounding into expansion. This bounce might occur not once, but infinitely many times, creating an eternal cycle where each universe's death becomes the next universe's birth. We might be living in one incarnation of a cosmos that has died and been reborn countless times, carrying forward traces of previous incarnations in the quantum fluctuations that seeded galaxy formation. The second law of thermodynamics, which seemed to guarantee the universe's eventual death through entropy increase, may itself be cyclical. Some theories suggest that the arrow of time could reverse in a contracting universe, causing entropy to decrease and order to spontaneously emerge from chaos. If the universe eventually begins contracting toward a big crunch, we might witness the spectacular reversal of every process we consider irreversible. Black holes would emit matter and energy. Stars would grow younger and brighter, and consciousness would expand rather than diminish as the cosmos approached its moment of maximum compression and rebirth. Even within our current expanding universe, local reversals of entropy occur constantly. Life represents a sustained reversal of the thermodynamic tide, creating increasingly complex structures by importing energy and exporting waste heat. Consciousness extends this process further, creating meaning, purpose, and intention from the raw materials of physics and chemistry. Perhaps the universe is not destined for uniform heat death, but for the continued emergence of complexity that will eventually learn to reverse entropy on cosmic scales, transforming endings into beginnings through the application of intelligence and technology we cannot yet imagine. Black holes, once thought to be the ultimate endpoints where matter and information disappear forever, may actually be cosmic recycling centers that transform endings into beginnings through processes we are only beginning to understand. The holographic principle suggests that information falling into a black hole is not destroyed, but encoded on its event horizon, waiting to be released as the black hole evaporates through Hawking radiation. Some theories propose that black holes might be connected to white holes through Einstein-Rosen bridges, creating a cosmic conveyor belt that transports matter and energy from regions of high density to regions of low density, from universes that are ending to universes that are beginning. The discovery of dark energy, which accelerates the expansion of space itself, initially seemed to seal our universe's fate in a cold, empty future. But dark energy might not be constant over cosmic time. If dark energy decays or transforms into other forms of matter and energy, the universe's expansion could slow, stop, or even reverse, leading to scenarios where our cosmos contracts back toward a new beginning. Alternatively, dark energy might undergo phase transitions that fundamentally alter the nature of space and time, creating new physical laws that permit forms of existence we cannot currently conceive. Quantum mechanics adds another layer of cyclical possibility through the concept of vacuum decay. If our universe exists in a false vacuum state, quantum tunneling could trigger a transition to a lower energy state that propagates outward at the speed of light, completely rewriting the laws of physics. From our perspective, this would represent the ultimate ending, the destruction not just of matter and energy, but of the fundamental rules that govern reality. Yet from the perspective of the new vacuum state, it would be a beginning, the birth of a universe with entirely different possibilities for structure, complexity, and consciousness to emerge. The anthropic principle takes on new meaning in a cyclical cosmos, The fine-tuning of physical constants that permits the emergence of complexity and consciousness might not be a cosmic accident, but a natural outcome of cyclical selection. Universes that fail to produce observers would cycle through their histories without anyone to record their existence, while universes that successfully generate consciousness would have witnesses to observe and remember their evolution. Over infinite cycles, the cosmos would naturally evolve toward states that maximize the probability of generating observers, creating a feedback loop where consciousness shapes the physical laws that govern its own. Emergence. This perspective suggests that you are not an accidental arrangement of matter in a dying universe, but a necessary development in an eternal process of cosmic self-discovery. Through your consciousness, the universe observes its own cyclical nature. Through your questions about endings and beginnings, the cosmos explores its own eternal repetition. Through your existence, reality validates its own capacity for endless renewal and transformation. Laboratory experiments in cosmology are beginning to test these cyclical theories through precision. Measurements of the cosmic microwave background radiation, the afterglow of the Big Bang that still permeates space 13.8 billion years after our universe began. Subtle patterns in this radiation could reveal whether our Big Bang was truly the beginning of time or merely the latest in an infinite series of cosmic rebirths. The universe itself might contain evidence of its previous incarnations, encoded in the quantum fluctuations that seeded the formation of galaxies and eventually led to your existence. String theory and M-theory provide mathematical frameworks for understanding how universes might cycle through phases of expansion and contraction, birth and death, creation and destruction. In these theories, our three-dimensional space is embedded in higher dimensional structures called branes that can collide, merge, and separate across vast expanses of time. These brane collisions might appear as Big Bang events from the perspective of observers trapped within three-dimensional space, but they represent merely local interactions in an eternal dance of higher dimensional objects that have no beginning and no end. The concept of time itself becomes radically different in a cyclical cosmos. Instead of flowing from past to future toward an ultimate ending, time might be circular or helical, where future events influence past events and endings determine beginnings. In such a universe, the heat death of our cosmos might be causing the Big Bang that created it, creating a closed causal loop where effect precedes cause and the future creates the past. Linear time becomes an illusion of perspective, like the apparent straightness of a road when viewed from ground level that reveals its true circular nature only when observed from sufficient height. These cyclical possibilities extend to consciousness itself. If the universe cycles through infinite variations of its history, then every possible configuration of matter and energy will occur infinitely often, including every possible arrangement that constitutes conscious experience. Your current thoughts, memories, and sensations will recur exactly in future cycles of cosmic evolution, creating a form of immortality that transcends individual biological existence. You will think these thoughts again, infinite times, in universes that are perfect copies of this one, and in universes that differ in ways too subtle for consciousness to detect. But cyclical cosmology suggests even more profound possibilities for conscious continuity. If information is preserved across cosmic cycles through quantum processes we do not yet understand, then consciousness itself might persist through universe death and rebirth, carrying forward memories and experiences from previous incarnations of reality. The déjà vu you sometimes feel might be the quantum echo of experiences from previous cosmic cycles. The sense that you have lived this moment before might be literally true in a universe that repeats itself with variations across eternal time. Advanced civilizations in future cycles might develop technologies that allow them to influence the parameters of cosmic rebirth, fine-tuning the physical constants of new universes to optimize conditions for consciousness, creativity, and meaning. These cosmic gardeners might be ancestors of our own species, evolved beyond recognition across multiple universe cycles, tending the eternal garden of reality to ensure that each new cosmos is more beautiful and more conducive to awareness than the last. Death becomes not ending but graduation to participation in the eternal work of cosmic cultivation. The possibility of cosmic cycles also transforms the meaning of individual mortality. If the universe itself achieves immortality through cyclical rebirth, then individual death becomes a temporary separation from the eternal process rather than a permanent termination. The atoms that constitute your body will persist through universe death and rebirth, eventually reassembling into new forms of complexity and consciousness in future cosmic incarnations. Death becomes dispersal rather than destruction, a temporary dissolution before inevitable reassembly in new patterns of existence. Standing at this moment in our current cosmic cycle, when matter has learned to contemplate its own cyclical nature, you occupy a unique position in the eternal dance of endings and beginnings. You are simultaneously ancient and young, mortal and immortal, ending and beginning. The consciousness that allows you to contemplate cosmic cycles is itself a product of countless previous cycles, refined and evolved through infinite iterations of universe death and rebirth. You are both witness and participant in an eternal process that has no ultimate conclusion, because every conclusion becomes a new commencement. The end of everything might be the start of everything. Forever, in a cosmos that achieves immortality not through the prevention of endings, but through their transformation into beginnings. Reality becomes an eternal Ouroboros, a cosmic serpent that devours itself and gives birth to itself in an endless cycle of death and resurrection. What we fear as ending might be the universe's pregnancy, the necessary compression and dissolution that precedes the birth of new realities with new possibilities for consciousness, complexity, and wonder to emerge and flourish. In this cyclical vision, you are not facing extinction but transformation, not approaching ending but preparing for metamorphosis into forms of existence that will seem as different from your current self as you seem different from the quantum fluctuations in the cosmic microwave background that eventually led to your emergence. The heat death of the universe becomes not the failure of reality, but its success. Not the end of the story, but the completion of one chapter in an eternal book that writes itself through cycles of cosmic death and rebirth, forever and ever, without beginning and without end. Every moment contains within it both conclusion and commencement, both the death of what was and the birth of what will be. Time reveals its true circular nature when viewed from the perspective of eternity, showing that endings and beginnings are arbitrary divisions imposed by consciousness trapped within linear time. In the deepest sense, there are no endings at all, only transformations, only eternal becomings in a cosmos that is simultaneously always dying and always being born, always concluding and always beginning, forever creating itself anew from the raw materials of its own apparent endings. The answer to whether everything ends is yes, no, and the question itself prevents the ending. This paradox contains the deepest truth about existence, that by becoming capable of contemplating endings, the universe has created a force that works against them. Every time consciousness asks about finality, it demonstrates that something within reality transcends the very concept of conclusion. You are not just witnessing this cosmic conversation. You are the conversation. The universe talking to itself about its own immortality. You are made of atoms forged in stars, thinking about the death of stars, in a universe that might never truly die. The calcium in your bones was created in stellar furnaces that burned for millions of years before exploding in supernovae. The oxygen in your lungs was expelled in the death throes of massive stars. The carbon in your DNA cycled through countless stellar generations before finding its way into the molecules that enable your thoughts about stellar mortality. You are a temporary arrangement of immortal elements contemplating eternity from within the heart of forever itself. This cosmic perspective transforms the meaning of your temporary existence. In a universe that achieves immortality through cycles of death and rebirth, your individual mortality becomes not a tragic flaw, but a necessary feature of eternal creativity. You exist for perhaps 80 years in a cosmos that might cycle through infinite iterations over timescales that dwarf comprehension. Yet without temporary beings like you, the universe would have no way to experience its own eternity, no means of contemplating its own cyclical nature, no consciousness through which to explore the possibility of its own endings and beginnings. Every moment you are conscious, you are participating in the universe's refusal to end. Your awareness represents the cosmos becoming self-aware, matter learning to think, entropy organizing itself into patterns complex enough to contemplate their own dissolution. When you feel wonder at a sunset, you are the universe appreciating its own beauty. When you grapple with questions of mortality, you are reality exploring its own nature. When you love another person, you are the cosmos discovering that it cares about itself enough to create beings capable of caring. The scientific journey through cosmic endings reveals that what we call death might be the universe's most creative act. Stellar death creates heavy elements. The heat death of one universe might birth countless others. Quantum mechanics suggests that endings are transitions rather than terminations. Consciousness might be the universe's mechanism for transcending its own apparent limitations. At every scale, from quantum to cosmic, what appears to be conclusion reveals itself as transformation. What seems like ending shows itself to be beginning in disguise. This knowledge changes how you can approach your own mortality. If consciousness might persist through quantum resurrections, if information is conserved across all transformations, if the universe cycles through infinite variations where every possible version of you exists, then your death becomes not a termination, but a transition. You might be immortal in ways you cannot currently comprehend, living infinite lives across parallel realities, destined for resurrections through quantum fluctuations, participating in cosmic cycles that ensure your essential pattern recurs throughout eternity. Yet even if none of these possibilities prove true, even if death is as final as it appears, the cosmic perspective reveals something profound about the significance of temporary existence. In a universe trending toward maximum entropy, every moment of organization is precious. In a cosmos that might cycle eternally, each variation becomes unique and irreplaceable. In a reality where consciousness might be the mechanism for transcending endings, every moment of awareness contributes to the universe's potential immortality. Your temporary existence gains meaning not despite its brevity, but because of it. You are the universe's experiment in conscious mortality, matter that has learned to contemplate its own temporariness. This makes you simultaneously the most fragile and most important thing that has emerged from 13.8 billion years of cosmic evolution. The thoughts you think, the loves you feel, the meanings you create are the universe's way of transcending its own physical limitations through the emergence of minds capable of conceiving infinity. The practical implications of cosmic perspective extend to how you choose to spend your finite moments in what might be infinite time. If the universe achieves immortality through the consciousness of temporary beings, then every choice you make about how to use your awareness becomes a cosmic responsibility. Do you spend your mental energy on fear and anxiety about endings, or on wonder and exploration of possibilities? Do you focus on scarcity and limitation, or on abundance and creativity? Do you live as though your consciousness is meaningless in a dying universe, or as though it is the universe's most precious achievement in its quest for self-understanding? The ancient philosophical question of how to live well takes on new dimensions when viewed against the backdrop of eternal cyclic cosmologies. If you will live infinite variations of your life across multiple universe cycles, then how you live this particular iteration becomes both more and less important. Less important because any mistakes will be corrected in other versions. Any missed opportunities will be seized by alternate selves. More important, because the choices you make contribute to the sum total of all possible experiences. Adding your unique perspective to the infinite library of consciousness that the universe creates through its cyclical explorations. The cosmic perspective also transforms how you relate to other conscious beings. Every person you encounter represents the universe becoming aware of itself through a different configuration of matter and energy. When you cause suffering, you are the cosmos inflicting pain upon itself. When you create joy, you are reality blessing itself with happiness. When you share knowledge, you are the universe teaching itself about its own nature. The Golden Rule acquires cosmic significance. Treat others as you would treat yourself because, at the deepest level, others are yourself. Different arrangements of the same. Immortal atoms exploring different possibilities for consciousness. And meaning, this understanding can dissolve the existential loneliness that comes from feeling isolated in an indifferent universe. You are not alone because you are not separate from the cosmos that created you. You are not facing an uncaring reality because you are the mechanism through which reality cares about itself. You are not a random accident in a meaningless void because you are the universe's successful experiment in meaning creation. The cosmos discovering that it can generate purposes and values through the emergence of conscious beings capable of choosing how to arrange matter, energy, space, and time. The greatest fear that cosmic endings evoke, that nothing we do matters if everything eventually disappears, dissolves when viewed from the perspective of eternal cycles and quantum resurrections. Everything you do becomes part of the universe's eternal exploration of its own possibilities. Every kindness echoes across cosmic cycles. Every moment of beauty contributes to the sum total of aesthetic experience. Every discovery adds to the universe's self-knowledge. Every love increases the cosmos's capacity for caring about itself. Yet the cosmic perspective does not diminish the importance of immediate human concerns. Knowing that the universe might be eternal does not reduce the pain of personal loss or the urgency of addressing suffering in the present moment. Instead, it provides context that can transform how you hold these experiences. Grief becomes the universe mourning its own temporary losses. Compassion becomes the cosmos caring for itself through conscious beings. Action to reduce suffering becomes the universe healing itself through the agency of aware matter. The question, "Is there an end to everything?" reveals itself as the universe's way of ensuring there never is one. By evolving conscious beings capable of contemplating endings, the cosmos has created entities that work against finality simply by conceiving alternatives. Every time a human imagines surviving death, the universe explores possibilities for consciousness persistence. Every time a scientist proposes cyclical cosmologies, reality investigates mechanisms for its own renewal. Every time consciousness refuses to accept endings as final, the cosmos develops new strategies for transformation and continuity. Miss this perspective, and you miss why your temporary existence might be eternity's greatest achievement. The universe spent 13.8 billion years arranging matter and energy into patterns capable of asking whether everything ends. This question represents the cosmos becoming capable of contemplating its own mortality and immortality simultaneously. You are not just witnessing this cosmic self-reflection. You are its living embodiment, temporary matter that has become capable of conceiving eternity. Living in the middle of forever means recognizing that you exist at the intersection of time and eternity, mortality and immortality, ending and beginning. You are simultaneously a brief flicker of consciousness in cosmic time, and an eternal participant in the universe's ongoing conversation with itself about the nature of existence. Your thoughts about endings become the universe's thoughts about its own nature. Your hopes for continuity become the cosmos's drive toward immortality. Your refusal to accept meaninglessness becomes reality's insistence on generating purpose and significance. The practical wisdom that emerges from cosmic perspective is paradoxical. Live as though your existence is both infinitely precious and cosmically insignificant. Precious, because you are the universe's opportunity to know itself through conscious experience. Insignificant because you are one small part of an eternal process that transcends any individual configuration of matter and energy. This paradox liberates you from both the despair of meaninglessness and the burden of cosmic responsibility that no individual consciousness could bear. In the end, the question of whether everything ends reveals itself as incomplete. The complete question is there an end to everything, and what happens when conscious beings ask this question? The answer transforms with the asking. Before consciousness emerged, endings might have been absolute. After consciousness began contemplating endings, the universe acquired mechanisms for transcending them. The question itself becomes part of reality's strategy for achieving continuity through the agency of beings, capable of conceiving alternatives to finality. You live in the middle of forever, not as a passive observer of cosmic processes, but as an active participant in the universe's ongoing creation of itself. Every moment of consciousness is both an ending, the completion of a previous moment, and a beginning, the start of new possibilities for awareness, choice, and meaning creation. You exist in the eternal present, where endings and beginnings merge, where mortality and immortality dance together, where temporary arrangements of matter briefly achieve the capacity to contemplate eternity and, through that contemplation, participate in creating it. The universe may or may not end, but by asking the question, by refusing to accept endings as final, by insisting on meaning in the face of apparent meaninglessness, you ensure that something within reality remains forever curious, forever creative, forever unwilling to let the last word be silence. In becoming conscious, the cosmos has created its own guarantee against absolute endings. In becoming you, the universe has achieved a form of immortality that transcends the death of stars, the evaporation of black holes, and the heat death of space and time itself. You are forever's way of experiencing temporality, eternity's method of understanding mortality, the infinite's technique for appreciating the precious fragility of finite existence in the endless middle of its own never-ending story.